So we left off right here. We're going to start with this part today. So far we've talked about how to write a direct variation equation, how to find our constant k from a graph, from an equation, from ordered pairs, and how to determine if it is a direct variation equation. This one is, or this part is, we know it's going to be a direct variation, or we're using the direct variation equation, but now we're missing a value. Could be x, could be y, doesn't matter. Usually when you get problems like this, it'll say something about whether it's direct variation or inverse, or it'll be just in a section that's just direct or just inverse. So you'll know which one you're doing. So there are two different ways you can go about solving this. I'm going to show you both, and then you'll have the option to choose which one you like better. Let's. One is, because we know that to find k, well, first, how would we find k? From the stuff we did yesterday? Y over x. So because we know that much, we could set up proportions to solve this. So we could say negative 4 over 2 equals y over negative 6. And then to solve proportions, we would cross multiply. So positive 24 equals 2y. Divide both sides by 2 so that y equals 12. Double check that this still works, that your k still works. Because here, if I divide these two, negative 4 divided by 2 would be negative 2. So if I put my 12 back in, 12 divided by negative 6 would also give me negative 2. So my k is still there, it's still constant. So that would work. So one way you could solve these is using proportions. The other way you could solve this is to actually find your value of k, write your direct variation equation, put with your k in it, and then put in the missing variables. It'll kind of look like this, but a little different. Before we do that, does anyone have questions on how we set that up, how we found that? I'm going to jump to 21. We're going to do this a different way. So now, we know that k equals y over x. So I'm going to take the numbers that I know, or that I'm given both of, 6 and 24, and I'm going to use that to find k. So 24 divided by 6. We know that's 4. So we can say our k value is 4. From there, how would we write our direct variation equation? We need to look back at the first page to see how we write that. Bless you. Y equals kx, and in this case our k is 4. So y equals 4x would be our equation. Bless you. Now that we know this equation, we could look at the one that we're missing. So here we're missing x, but we're given y. So we can put that y value in and then solve for x by dividing both sides by 2. I could check to make sure this still works. If I were to find my k value, negative 16 divided by negative 4 is 4, so my k works. Or I could put this back into my equation. 4 4 times negative 4 is negative 16. Both of those work. So you have different options. You can either set it up using a proportion, or you can find your constant k, find your equation, and then solve your equation for whatever missing variable you need. Does anyone have questions on either of those two methods? So moving forward, again, you'll have the choice. You can do one, you could do the other, you could do both. It's really up to you. I'm not going to make you do one or the other. It's whichever you choose. Let's do a couple more, and then I'll let you try some. And then we'll move on to some application ones. For 22, instead of it being in ordered pairs, now it's written out in words, but you're still doing the same thing. So one we'll do by proportion, and the other we'll do using this method. You have to remember that your k equals y over x, so I'm just going to write that off to the side. So to set up this proportion, I could say negative 18 over 3 equals 30 over x. Let's multiply and figure out what x is. So here we'd have 90 equals negative 18x. Divide both sides by negative 18. I think that's negative 5, but double check that. Was that negative 5? Yeah. Yes, thank you. And then to double check that my k value is constant throughout both of these, negative 18 divided by 3 is negative 6. 30 divided by negative 5 is negative 6, so that works. And then let's do 25. I'm going to go back and do it the other way, where we're finding k and then finding our equation and solving it that way. So for this one, these are the two numbers we're given. So we need to do negative 7 over negative 28 to find k. We could simplify that, divide both by negative 7 to get positive 1/4. Our equation would then be y equals 1/4 x. And then in the second part, we need to find y, and we're given x. So we're going to be multiplying 20 by 1/4. Or really dividing 4. So y would equal 5. And we could double check that two different ways. 20 divided by 4 is 5. And then if I put 5 back in here, 5 over 20 is 1/4. So my k value is still there. Bless you. Anyone have any questions on any of this so far? I want you to take the next 5 or so minutes to do the 4 we didn't do. So 19, 20, 23, 24. and then we'll come back and we'll talk about them. So the method, this isn't my handwriting, but the method that's up here is just the proportions. If you solved it the other way and want to see that, just let me know, and I can do that for you. But I'm just going to go over the answers, unless otherwise. 19 was x equals 6. 20 was y equals 21. 23 was x equals 40. 24 was y equals negative 30. Anyone have questions on those or need to see any of those the other way? The other way. Oh, did we do? Never mind. Okay, so for 23, we would do 80 over 32 to find k. I don't know what that is. That would be your value of k. Your equation would then be y equals 5/2 x. And then you're given y equals 100. And you need to find x. So to get rid of the 5/2, you could either divide by 5/2 on both sides or multiply by the reciprocal. So those would cancel. This would become 200 over 5, whatever that is, equal x. My brain's not working. 40, I'm assuming.
Yeah.
Thank you. Any others? Move on to the next page. My pages are out of order. You guys don't have this part. You'll see it again when we get to inverse application. Two important things about applications of direct variation. Examples, equations, whatever. One thing you'll notice is as one variable goes up, the other goes up. So they either rise together, or it could be the opposite. As one goes down, the other goes down, they fall together. You can kind of think about that as a line. They either go up together or they go down together. What's nice about the application problems is the work we just did, the proportions are doing it the other way. We're going to do these the exact same way. So these are really just like missing number problems, but now they have words attached to them. So we're going to go through one, read it, and we'll solve the first one by proportions, the second one using the other method, and then we'll do one more of these, and then I'll let you try them. The sales at a baseball game vary directly with the number of people attending. If the sales for a game are 12,000 when 800 people attend, determine how many people attend if the sales for a game are 15,000. The other thing that's really nice about these problems is that it tells you somewhere what you're doing. So you should see words like vary directly, varies directly, or when we get to inverse, it'll say something about varying inversely, inversely proportional, something that will tell you what you're supposed to be doing. So if you're using proportions here, you need to know what's your X and what's your Y. What's also nice about these is whatever comes before the words varying directly. So in this case, your sales at a baseball game, that would be your Y value. And then the words that come directly after varies directly, whatever it says. So in this case, the number of people attending, that would be your X. So now that we know that's Y, that's X, then when we go to set up our proportion, we know it has to be Y over X. The sales would be 12,000. Our number of people would be 800. Equals, for the second part, we don't know how many people are attending. That's our X, so that would be in our denominator. But we know the sales are 15,000. Set up the exact same way, there's just a lot more words. So we could cross multiply. I'm doing this from memory, so if this is not right, correct me. So this one I think was 12,000 X equals 12 million.
I don't understand this.
We're multiplying 815,000.
Oh.
And then 12,000 in X. And then dividing both sides by 12,000. So our X would be 1,000, and because these are word problems, we need units, so 1,000 people. Before we move on to another example, does anyone have any questions on how we set that up? How we got any of those things? How we got the answer? For the second one, ounces of medication, very directly, there's that word again that tells us what we're doing. With the weight of the patient, if a 120-pound adult requires 3/4 of an ounce of medication, how many ounces are required for a 200-pound adult? So this one we're going to solve using the other method. So we need to know what our Y and X are. In these, if you don't want to use Y and X, you're perfectly fine to change the variables. You would just need to let me know what you change it to. So if you want to call this M, call this W, that's fine. You would still need to know, okay, would M be my Y or my X to put it in the equation or the proportion, either way. Ounces of medication is still going to be your Y, or if you change that variable, or you change it to. And then weight of the patient is going to be your X, or whatever you change that variable to. So if we're doing this the second method, we need to find our K, which would be Y over X. And the two things that we know, they told us they need 3/4 of an ounce. Because that would be a fraction, I'm going to use a decimal because then you would have fractions within fractions. The 0.75 would be our Y. The weight of the patient would be 120. Put that in your calculator, figure out what that is. 0.0062. That is right. A lot of these, unless you have big numbers like the first one, you're going to end up with some sort of decimal for k. So once we have this, we could put this in our equation. Y equals 0.00625 x. The second part of this says how many ounces, so we're looking for y, and we're given the weight, which is 200. So we can put that in for x and multiply. Someone do that in your calculator. 1.25 and 1.25 what? Ounces. So just as both methods work for the missing value questions, same thing here. You can use either or. You like one more than the other, stick with one. If you don't mind either or, you can use both. It doesn't matter. We're going to do one more together, then I'm going to let you try the other three. Before we do that last one, does anyone have any questions on how we are setting these up, solving them, getting the answer, anything like that? For the last one, we're going to do 5. So for 5, the income of a computer analyst varies directly as the number of hours worked. If the analyst earns $256 for working 8 hours, find the constant of variation. So in this case, we're not looking for like an X or a Y, we're looking for K. They give us the two numbers, so we just have to find what K is. You do still need to know what Y is and what X is, but that can easily be determined by looking at the first sentence. So the income of a computer analyst would be your Y. I highlighted that in a different color. All right. The number of hours worked would be your X. So to find our Y over X, we would use 256 over 8 and figure out what that is. What would that be? I'm going to type this really fast. I don't believe this had units, but it could, and I could be mistaken. So make sure you know what it's looking for, because you could do a bunch of work and it's not even looking for all that work. Okay. With the last bit of class we have, time in class we have, okay, try these 3 problems, and then right before the end of class we'll go over them so you have those answers. Again, these were all done by proportions. If you need to see any of them done the other way, just let me know. For 3, there were 10 shares. 4 was 750 bushels. And 6 was 6. K was 6. Questions on any of those 3? Tomorrow we're going to be starting inverse variation, which is very similar to direct, but also not at the same time. And we'll be working on that tomorrow and Tuesday, or if we have a code orange, whatever day we come back to. You guys have 4 Khan Academies on direct variation, a lot of it is just finding the constant K. I know I said this yesterday, but I'm just repeating it. One is like finding constant K from equation, one from tables, one from graphs, and then one is can you write the direct variation equation. Make sure you try those, get those done. If you want to go through them with me, you can stay up until today or come in the morning tomorrow.